Good day, ladies and gentlemen. Today we are talking about polynomials. I send my greetings to all of you wherever you are, and I want to teach you something about polynomial expressions and polynomial equations. So let's talk about polynomials. What is a polynomial? A polynomial function in X, it can be X, it can be Y, it can be any variable, but here we are dealing with X as a variable. So a polynomial function in X is an expression involving powers of X, normally arranged in descending or sometimes ascending powers. So you have an expression which is involving powers of X, okay? And the powers either keep on increasing or they keep on decreasing, okay? So if we are dealing with the powers of X, then we have to know something about polynomials that we call the degree of the polynomial. So the degree of the polynomial is given by the highest power of X occurring in the expression. Okay? You are given an expression which is involving powers of X, and the powers are either in descending or ascending order. So what we call the degree of a polynomial, just look at the highest power of X appearing in the expression. Okay? If we have an expression like a 5x to the 4 plus 2x cubed plus x minus a 4, okay? This is a polynomial because we see the powers of x, they are arranged this time in descending, okay? You have the highest is 4, from 4 you go to 3. There is supposed to be a 2, but sometimes some powers are omitted if the coefficients are 0, okay? So this is cubed, then it drops to 1, and then this 4 has x to power 0, but you know x power 0 is 1, so we don't write it, okay? So this is a polynomial of degree 4, okay? Is a polynomial of the 4th degree. So it is just easy if you are if you have been asked to tell the degree of a polynomial, just look at the highest power of x appearing in the expression. Remember, this is an expression involving powers of x either arranged in descending or ascending order. Okay, so for this case, we are having the powers of x dropping from x to the 4th up to x0. So this is a descending order. All right. The field of polynomials has a wide application, basically in cryptography, where we encode the messages and send them and decode. Okay, but here I'm going to stick basically to the ring of rational numbers. Okay, so I will not talk about polynomials in the modular mathematics where we are dealing with the prime field, so what, but I will stick basically to the field of rationals. So we are going to talk about polynomials in the ring of rational numbers. Okay, that's what I'm going to stick to for beginners. Okay, when you advance more and you want to study polynomials at the higher levels, then you'll be talking about polynomials over different fields. So since we are saying that the highest power gives us the degree of the polynomial, so what will be the degree of this polynomial? 8x cubed plus 3 plus a 7, okay, is a polynomial of the third degree. So polynomials of low degree often have alternative names. So if you have polynomials of low degree, they often have alternative names. You know, the degree of a polynomial ranges from 0, 1, 2, up to about, you can even have 1 million, polynomial of degree 1 million, okay? But these polynomials of low degree, they often have alternative names, okay? Let's see if we have 3x plus 4, okay, is a polynomial of degree, okay, yeah, is a polynomial of degree 1, okay, and basically these are called the linear expressions. So this is a linear expression. Anything of degree 1 is linear, okay? If you have 2x squared plus 3x plus 5 is a polynomial of the second degree. And the second degree polynomials are called quadratics, okay? That is a quadratic expression. You have dealt with the quadratics. So a polynomial of degree 2 is called a quadratic expression. Degree 3, we call them cubic expressions, and degree 4, they are called the quartic expressions. If they have equal signs, of course, they become equations, but right now we are still dealing with the expressions. So this is a quadratic expression. Next, let's talk about evaluating polynomials. What do we mean by evaluating polynomials? To evaluate a polynomial is to find the value of a polynomial if you have a given input. Normally, if a polynomial is defined in terms of x, we write f of x, for example, is equal to 3x to the power 4 minus 5x cubed plus 7x squared minus 4x plus 2. That's a polynomial of degree 4, okay? If we want to evaluate it at the value of a variable x is equal to 2, what do? We substitute x equals to 2. We look at the individual terms, evaluate the individual terms, and then sum them together. So what we get will be the value of the polynomial. So this is 3, okay, 2 to the 4th power minus 5, 2 to the 3rd power plus 7, 2 squared minus 4 times 2 plus 2, okay? And you go ahead, manipulate this, okay? Now what you do, find the values of each term. Just go ahead and find the value of each term. This digital pen. And then after, we add the values of the values we get for each term, and then find the value of the polynomial. We have evaluated the polynomial at a point x is equal to 2. Okay, so if you go ahead and find the values of each term, you discover that f of 2 is about 53. Okay, now let's do it. Why should we say 53 when we can do it? Okay, 2 to power 4 is 16. 16 times 3 is 48. Okay, 16 times 3 is 48. Okay, minus, okay, 2 cubed is 8 times 5 is 40, plus 7 times 4 is 28, minus 8 plus a 2. So this is 8, this is 20, 22. Okay, so we get the value of 30 and not 53. So f of 2 in this case will give us 30. Okay, we have evaluated the polynomial at x is equal to 2. Okay, so why don't you go ahead and try this? It is something very simple. Suppose you are given f of x equals to 3x to power 4 plus 2x squared minus 4x plus 5. What is f of 2? F of 2 equals, okay, go ahead and try and see if you get my answer. Calculated answer is 53. Okay, you go ahead and try it out. You know, when you are doing mathematics, you don't just watch a video. Okay, the good thing with the digital age is that if I post this video on YouTube and you are watching it, you want to learn, make sure at some point you pause and work out what I'm trying to tell you. Don't just watch and think you learn mathematics. No, you have to be part of the lesson by participating. Okay, so go ahead and evaluate this and see if you get 53. Okay, that's what we mean by evaluation of a polynomial. There are some simpler approach for finding higher powers. It gives you hard time. We can try to write a polynomial in nested form. Then after we feed in the value, let's just check how this is done. It's just something very simple. So here I'm giving a short exercise as a student. Okay, I want you to just evaluate these polynomials by nesting. You remember, nesting not so important. It's just an easy way of evaluating a polynomial, just to make your life easier. But if you have a calculator, you don't need to go into the details of nesting. But I will just pick one of these questions, these problems, and I try to just brief you about the idea of nesting. Evaluation of a polynomial by nesting. Let's see. So we are picking f of x equals to 2x to power 4 minus 5x cubed minus 3x squared plus a 4. And we want to evaluate this polynomial at x is equal to 4. Okay, what do we call nesting? Nesting is just trying to simplify your life. I look at this as 2x minus 5. Okay, then I create a bracket. I subtract it. So there is an x here. I subtract a 3. Okay, I create another bracket. Okay, then this is multiplied by x plus a 4. As simple as that. So you can use a substituting. This is 2 times 4 minus 5. The answer you get multiplied by 4. Okay, after subtract a 3, okay, the answer you get, we would even have made this 3x. Okay, the answer you get multiplied by 4. Then at the end of it, we multiply by 4 and add a 4. Okay, what do we get? 2 times 4 is 8. 8 minus 5 is 3. 3 times 4 is 12. 12 minus 3, okay, what we get multiplied by 4, and after we multiply this by 4 and we add a 4, okay. 12 minus 3 is 9, okay. 9 times 4 is 36, so the answer will be 36, okay, times 4, then after you add the 4, okay. What is it? 6 by 4? It is a 24, which is a 4, and the 4 by 3 is 12, so that is 144 plus a 4. The answer will be 148. Okay, so you have evaluated the polynomial by nesting. But it's not a big deal. Just in case you don't have a calculator, you're working by hand, and you have been told to evaluate a polynomial, you can use this method of nesting, but it's not really give you hard time, or it's not be something of concern. All right, let's move on. One of the areas why we study polynomials is sometimes we divide two polynomials to get another polynomial and a remainder, okay? So let's talk about the remainder theorem. Remainder theorem. So what's this theorem? Okay, what should we know about the remainder theorem, and how useful is it? All right. So what's the remainder theorem? The remainder theorem states that if you get a polynomial f of x and divide that polynomial by x minus a, then you are going to get a quotient which is still a polynomial, but it will be degree 1 less f of x. And there will be a remainder r still to be divided by x minus a. So this is what they are saying in simple terms. If we get f of x, which is a polynomial, and divide by a linear function x minus a, then we are getting g of x. Then there will be a remainder r to be divided by x minus a. And this is what we call the remainder theorem. Get a polynomial f of x, divide that polynomial by x minus a, you'll get another polynomial which is g of x, that's the quotient, okay, and there'll be remainder r to be divided by x minus a. So that is what we call the remainder theorem, okay. So we can change this. We have to multiply through by x minus a, and we have it in this form. So f of x, if you cross multiply, or if you multiply through by x minus a, you get g of x, okay, this multiplied by x minus a plus the remainder, okay. And we can try to evaluate this when x equals to a. We're going to have f of a equals to g of a times 0 plus r, and the f of a will be equal to the remainder. So we can always get the remainder by substituting in the polynomial x is equal to a, okay. So ia or r is equal to a. So if f of x were to be divided by x minus a, the remainder would be f of a. Okay, if you were to divide the fx by x minus a, the remainder is the value, okay, when you try to evaluate f at a, okay. So let's talk about this. So x cubed plus 3x squared minus 13x minus 10. If you divide this by x minus 3, what would be the remainder? This would give a remainder r equals to f of 3. Just substitute x is equal to 3. Look at that x value, which makes, okay, x minus 3 0, and substitute in the polynomial, then what you get will be the remainder. Let's do it and we see what we're talking about. So we want to find a remainder if we have been given f of x equals to this, and they are saying we divide it by x minus 3, so they want the value of the remainder. This is the remainder theorem. Okay, we are just trying to talk about the remainder theorem in this step. Okay, and if you go ahead and multiply through by x minus 3, then you're going to get x cubed equals to this part. Okay, so if you go ahead and substitute x is equal to 3, because the value you substitute to get a remainder is what makes this part 0. So x is equal to x minus 3 is equal to 0, x is equal to 3. Substitute x is equal to 3, you will end up with the remainder as 5. Okay, and we can verify this by long division. Let's try to do it. So let us verify this remainder by long division. What do we do in long division? We are having x cubed plus 3x squared minus 13x minus 10, and we are dividing this by x minus 3. So you get x cubed and divide by x, so this is x squared. Okay, x squared multiplied by everything here. Okay, multiply everything by x squared, you will get x cubed minus 3x squared. Subtract. Okay, remember when you are subtracting, the negative affects everything, so it's always good to put a bracket. This time this minus this, x cubed minus x cubed, you get 0. Okay, negative and negative is a positive, so this will be plus 6x squared minus, of course here they are zeros. Okay, so we say minus 13x minus 10. Okay, now next we get 6x squared and divided by x, you have plus 6x, so this will be 6x squared minus 18x. Subtract. Okay, so when you subtract, what do you get? You'll get, this is a 0, negative, and the negative is a positive, so this is a positive 18x minus 13, so plus 5x minus 10. Okay, 5x divided by x, you are having a 5. This is plus 5. So 5 times x, you get 5x minus 15. Let's subtract. Okay, this is a 0 plus a 5. Now we can divide the 5 by x. Okay, so this 5 is the remainder. That value you always have at the last point when you cannot further divide is what we call the remainder. Okay, so it means that x, oh sorry about this, it will mean that if you get x cubed plus 3x squared minus 13x minus 10 and divide this by x minus 3, then you are getting x squared plus 6x plus 5. And your remainder is 5 to be divided by x minus 3. Now, this step is what we have been talking about as the remainder theorem. When you count the wrong division, you will always get the remainder theorem, coming out. Okay, this is what we have been calling G. Okay, G of x. G of x is a polynomial of degree 1 less that of f of x. You can see that f of x here has degree 3 and G of x here has degree 2. So this is the remainder theorem, and therefore the remainder R is equal to 5. Okay, but we found it by just evaluating the value of the polynomial at x is equal to 3, and we have got the same result when we carry out a long division. All right, let me give you some small work here. Let me give you this small exercise about finding the remainder if you are given a polynomial and then the divisor. Okay. So I'm giving you this simple exercise. Just apply the remainder theorem to determine the remainder in each of the following. Okay. In each of the following, I left out one word. Each of the following cases. So I've given you polynomials, then the divisors. Okay. So you go ahead and apply the remainder theorem and find the remainder. But I will put for the answers here. These are my answers. This is 24. This is 225. And this is 0. Try it out and see. Once again, I'm not saying that my answers are too accurate, but at least I try to be careful when I was trying to calculate these answers. So you go ahead and work out and see if you get these answers. Next time, we are going to discuss the factor theorem, and we get to see how we use the factor theorem. Then we shall start factorizing polynomial expressions. So don't miss my next video that is coming ahead. Remember to subscribe if you have not yet subscribed, and click the notification bell. That way, if I upload a new video, you'll always be notified immediately. All right, have a good day.